Greetings, good morning, good afternoon, good evening to everybody. This is a brief demonstration of what LoOper is. I've been working on it for the last 5 months with the purpose, well, at the beginning, with the purpose of automating my own tasks and creating workflows that make my life easier. This project mutated a lot through the months, becoming some kind of combination between common RPAs like Automation Anywhere or Power Automate with apps that you can use online like N8N and others. The idea of this is not relying in the cloud, not relying in other corporations, not relying in nothing else that is not your own system, your own PC, your own resources, and your own privacy. Um, as this is a brief demonstration, I am going only to show you how each node works for you to explore it later when I launch it, and a simple automation that I made just for this case. So let's begin. Here we have different items in the taskbar. This is the scheduler. We can use it to schedule different algorithms to be executed at certain times or in specific iterations. Here we have the preview that lets us show or not this bar that we can actually drag from the side whenever we want. Here we can go out, set up the AI systems. This is running with Olama, so all the API calls are going to be local. You can actually use another computer you might have as a server just to connect to it and run the inference on it. I can teach you later how to do that. I'm using Tailscale mainly for that, but you can already start the API locally directly within the app. You can do it with toggling this little square. How everything works. Okay, we have different types of nodes. The first ones are the sequences, things we can actually record. For example, let me record something. Um, let's say I want to open just the folder we have on the taskbar on the bottom. Open folder, it's going to be the name. Then we press escape. Oh, I think that the folder was not visible, right? Okay, we pressed escape, and what the system did was just recording your actions, your actual actions on the system, and saving them in a JSON format for you to later use it as a node. You can execute, and it will repeat your process. The funny fact of this is that at the beginning I was using something like more direct, like if it was something um, touch, let's say. But right now I'm using a pretty complex algorithm to make the movements smoother. So this system is allowed to interact with any website, any app, and it's not going to be detected as a bot in any case. It doesn't work like Selenium. It is not tied directly to any kind of browser or cloud service. You can even run it without having connection to the internet. Let me get that sequence for you to see its open folder. It's going to appear as this little gray square, which I'm going to play through this bottom. I'm not touching anything right now, just to make it clear. Okay, didn't find it. Um, okay. That's because it is out of the. Okay, it has to capture everything in the screen, and as I'm limiting the screen visible, it is not going to find it. But let me re-record it to find something in the screen itself. Instead, sorry. Second, I have to mention that if you don't click in places that are clearly different than others, it is going to pick a random match between all the ones. because as you see, I have many folders here. It just picked the best match at the beginning, and this was the projects folder I had already here. Then we got, of course, we can copy and paste, select everything, move. Um, we can delete, of course, with sub. We have LLM nodes, which are actually instances of large language models so you can run directly on your system. You can edit them. I'm going to update the models that I have available here. And as you can see here, I have only local models. I'm not using any API, any external resource or anything. I'm going to use this one for now because this is a very slow machine. And the purpose of making the demonstration here is to show that it can work seamlessly in very old machines. This is an instruct model I can download directly from Olama. Here we can give it the indications like the system prompt and our prompt. We can use Tesseract OCR to extract the text from the screen. We have different templates. We can modify the confidence. We can connect nodes between them to make agents. That's going to be shown in further demonstrations because this is still under corrections. It works, but it just needs some corrections yet. Um, we have different rack mechanisms here. For example, the most important one that I'm using is just plain embeddings for vision and for screenshots for it to extract text or understand what it's happening in the screen. And then we have something very important, the Como rack, which is rack architecture that uses multiple instances of an AI to digest the task you give it in multiple parts and then output, even if you are using very small models, very long responses and having, let's say, a very aware instance of each model because it kind of goes digesting the content in multiple parts, and this makes each response way more accurate. I would truly recommend using this for writing essays or doing investigation and other things. For now, I'm just going to toggle it off because it's going to take a whole lot to process here. And then I'm going to say that, oh, the templates. Uh, 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 uh. Let's say I want to summarize some content. And I want to ask um, what does the theory of chaos talk about? And then a question. We're going to let the model to write by itself by toggling this option. We're going to open this here just for the sake of seeing how it writes by itself. And it finished and pasted the response. It also made the AI to drag the OCR from the screen, like the characters it recognized. And we also can see it captured something from the screen, which was expected because I put it the OCR directly for it to use it. Then we have chain imports. This is a very special node because it can be used for making callbacks and other things, and it lets you import different parts of other chains for you to use it in other chains. It's complicated, but it's kind of a nesting node for you to create complex workflows without having to see the whole behavior and the whole workflow in the same page, which I believe it's something very important because I've seen many N8N workflows that are pretty big, and that kind of makes me lose the focus when looking at a workflow someone is trying to share with me. I'm going to show this one later because I already have something prepared for you. This is the TTS node, which we can use to just speak or say something. In this case, we can change the language. I have to correct the GUI first. If we play it,
Ello, this is a text-to-speech test.
it will just speak whatever you put in there. I use this mostly for debugging my own workflows in case I have something that I don't know yet how to do. It is going to say whatever it got stuck or whatever it got like stopped for some reason for me to review it later. And then we have the core, the key of every workflow here in the conditional node. It has one input and two outputs, true one, false one. It allows you to add presence triggers. You give it an image. That image it's going to validate or not, depending on what it says in the screen. You can give it a timeout or not giving it a timeout for it to wait the amount of time that it has to wait for something to appear on screen to do something. In case you give it a timeout, once it timeouts, it will take the false branch and effectively branching your workflows. Then we have the same thing, but with OCR, you can give it a text. The text it's going to be searched on the screen, and if it finds the text, it will output true, and if it doesn't find the text, the same but for false. With this toggle, you can distinguish between uh, capitals and not capitals. Oh, and the conditional loops, which is actually very simple. It's a simple validation node, but repeated on over the time. You can use two templates, while present and until present. You give it a sequence like this ones, you can see here, and you can give it an image or an OCR trigger. It will do something the amount of times you have put it here until the condition you give here is confirmed or not. If it doesn't have any more retries, it will output directly false. And if it just accomplished its task, it will output true following the correct workflow, the correct branch. I'm sorry. As you may already noticed, this is to record, this is to open chains, this is to save chains, and this is just to play the workflows you have on screen. Let me open a simple chain that I made, and I'm going to explain how it works very briefly. For the ones that just followed me, you might have seen that I've been following a lot of people and sending messages. This simple chain is the one that has been doing all that work. We have here a node that opens the browser, a conditional that validates if the browser has something open to avoid closing important tabs. If something is open, it will directly, if something is not open, sorry, it will go directly to LinkedIn. If it's not open, it will create a new window and then go to LinkedIn. Here we have a chain import, which was the important part that I wanted to explain. These chain import nodes, you can edit them and put inside of it a chain. And when I mean inside, I mean literally inside, because you can expand the chain and see that inside of it we have another chain, which is composed of other nodes. Here we have three chain imports, which are calling other chains. A conditional. If we expand this chain, we get another one. Here you have an LLM node that it's going to take care of searching for keywords in order to always try searching for a different kind of position for me to expand my own network, um, like I would do without having something fixed, let's say. Here we have another chain, which is very similar, but it is a variant that it's used in case something is not present, which is the reason that why I put it that conditional before. And here we have the connection loop, which is a simple visual algorithm. Here we have a conditional. If the conditional it's not able to validate, it will go for another conditional with a different condition for the system to know in which state is the screen for it to take the correct branch. So in case I'm not going to go so deep in these conditionals, I'm just going to show it to you. In case it finds it to be true, it will take the true branch, go to the next, and call himself again. This is a callback function, which means this chain import, I give it the same chain that this one is. So it means once it gets here, it will call again itself going to here for it to start again. Same thing here. It takes the false branch, it scrolls, and then when it finished, it just calls himself again. We have here, in case this is valid, it will connect. It will see if we can connect, if we have connections left, maybe if the connection was truncated for some reason. And in that case, if the connection is truncated, it will directly go through this, which makes the system to ignore the contact that was truncated and then call itself again. If the connection was not truncated, it will just send the invitation. We can actually here put something to write a note, but for this quick demonstration, I just wanted to avoid that. This is going to send the invitation without the notes and then call himself again. I don't want to be recursive, so let me just run this chain for you to see. 1 second. I'm gonna put this here. Okay. Now it is going to pick a random job title for me to connect with some people, and it's going to write it on there. Remember, this is running completely locally, and this is just a laptop, a very old one, running Windows 11, which is hard enough to run for most computers that without the correct hardware. As it is not going to find any connection here, it's going to scroll until finding a connection. And as you see here, it found a connection, which is going to click now. And it will send it without any notes. This is the moment when it calls again for itself. That's why it is scrolling, because it calls itself. It sees that there's no connections in the current screen, so it's going to just try to do it again. And if it doesn't find any connection and sees the next button, well, that's what you see. If we press escape, we can actually stop the sequence. Even if it is in the middle of an action, it will stop immediately. Let me stop it. And I will show you something very important. With conditionals, you can actually make the system aware of the state of the screen. So it is, if it is in the state it desires for to do something, it will skip the first part and go directly to whatever it has to do next. In this case, is not going to open the browser again. It's not going to try opening LinkedIn again. It will directly go here, change this for another job title, and then try again. So, oh, that's my bad. That's my bad. I'm sorry. Well, just to be clear, that was my bad because I needed a new conditional here to avoid opening Brave because this is the first sequence, so it is always going to open Brave. So I'm gonna open this one, which is the general one. There you go. And as it is in the screen of searching, it sees that there is already a search, so it will remove it and then search a different keyword. Nice. We can see that there are lots of connections here to make. Well, that's the whole demonstration. I hope you liked it, and hope get you get me a follow up. I will be releasing LoOper in the next weeks with the help of a coworker that I'm talking right now. It's from Cybernet. It's a small company from Chile, and well, that's kind of it. I don't have anything else to say, so I will cut the recording and the workflow right now for it to avoid just sending more contacts. Goodbye and have a really good day.